Hi, Johnny. Hi, Anna.
Hi, Misha. Hi, Anna.
Good morning.
So, welcome back. Second day of .next. I'm very happy to be here again. Good morning. Hi, Anna. Hi, Misha. So yeah, yesterday we started with this workshop, building cloud-native applications with .NET 5 and Azure Kubernetes Service. Yesterday we talked about .NET 5 specifically, all the different templates that we have to create different kinds of cloud-native applications. I talked a little bit about Docker and containerization with Docker. And then today, finally, we will see all of this come together when we deploy our containers into a Kubernetes cluster, and more specifically, an Azure Kubernetes cluster. So, Anna, did you like the workshop yesterday so far?
Yeah, I enjoyed, and I try to follow you to some point. Actually, I have some private questions, not private, but some questions about gRPC and several others. For example, let me ask them in discussion zone. But this night for me was pretty tough. And could you please help me to recall at which step we have finished yesterday?
Yeah, so I've created a GitHub page specifically for today and yesterday, of course. So let me quickly verify. So we did part 1 and part 2 yesterday, so that's step 1 until step 14. And then today we will start part 3 with step 15.
Yeah, I recall we discussed the connection, my Azure, or not mine, but Azure subscription to Visual Studio Code. And as for me, I did it through CLI, and you advised to do it through something else, maybe.
Yeah, you can do both. So in Visual Studio Code, there's different extensions you can use to connect to cloud environments, for example, Azure. So you can use Azure CLI, which uses the terminal window inside of Visual Studio Code, but you can also use the command palette inside of Visual Studio Code. So that's the little box in the top where you can search for commands, and that's a separate extension that you can install, and then all of those Azure commands are part of that thing. And it works more like a wizard. You type a command and it will ask you several questions until you reach your final point to whatever you want to do. And that is something that we will use extensively today.
Okay, so sounds clear. Thank you.
All right, perfect. So I guess we're ready to start. So let's go. Welcome back, part 3. As I discussed yesterday, 3 parts, 2 parts yesterday, 1 part today. We are only going to write a little bit of extra code today, and with code I mean C# code. There's going to be one additional part of our application, so that we have the web API, we have the worker service, and then today we will create an additional web application. These 3 applications, we will deploy them into our Azure Kubernetes service in Azure. And then I can explain to you what Kubernetes is, how it works, what the different parts of Kubernetes are. And of course, we only have 60 minutes or 70 minutes. So I can't discuss everything, but this should give you a basic understanding of Kubernetes, and then it's all up to you to start playing around with it, learn a lot from the internet. There's lots of videos, lots of information about Kubernetes. So let's just shut down my personal slides. We don't care about slides anymore. And let me very quickly also show you again the GitHub page, if I can find it. There we go. So this GitHub page specifically for this workshop is here for you. You can always use this as a reference. I am describing all of the prerequisites right here. So what do you need to install to be able to do the same thing as what we are doing today and yesterday? And then we have all of the different steps. Today we will start with step 15. To create the Azure Kubernetes service in our Azure subscription. So I can go to my Azure page. So Kubernetes is an open source product for container I can't find the word, to host your containers, basically, for container orchestration. That's what I wanted to say. So Kubernetes is an open source tool for container orchestration, which means that you can deploy your distributed application or microservice application into this Kubernetes cluster, and it will be managed inside of this cluster in a whole. So you can deploy all your different components within the same cluster. You can manage it within that cluster, and you can configure communication between containers. You can configure communication from the outside world, and you can basically have that as your entire environment. So in Azure, I already created a resource group yesterday. So this was my resource group for cloudnative.next. And I'm going to add a new service to this. So in Azure, you can search the marketplace for Kubernetes. You will find the Kubernetes service. So the Kubernetes service is actually an implementation specifically for Azure. And so Microsoft has created a template for Kubernetes to be deployed inside of your Azure subscription. And Kubernetes is quite complicated. It's a big product. There's lots of components inside of Kubernetes. And if you want to install that on a local environment or an on-premise server farm, it's going to be a lot of work because you have to do all of these configurations manually. But if you host it on Azure or another cloud service, they can help you to do lots of that configuration for you. So let's just, instead of talking about it, do something. So I'm going to click the Create button. And just like every service in Azure, I need to pick my subscription, I need to pick my resource group, which is already here, and then I'm going to create a new cluster name. Why is it called a cluster? Because a Kubernetes service will actually be installed on a cluster of virtual machines. So there's going to be a number of virtual machines that will host your Kubernetes cluster. So I will start typing my name. So it's going to be my Azure Kubernetes Service .next workshop. I'm going to put it in West Europe because that's where I'm located. And then you can pick the Kubernetes version. I told you before, Kubernetes is an external product. It's an open source product. Microsoft is just implementing it in their own environment. So I'm just going to leave for the default version. But if you want a specific newer or older version than the default version, you can do that. And then very important, a Kubernetes cluster, as I told you, is built on top of a number of virtual machines. So Azure will automatically allocate a number of virtual machines depending on your node size and node count. So what does this mean? The node size is the kind of virtual machine you want to use. So in Azure, you can change the size of your virtual machine, and there's many offers. There's different kinds of virtual machines. Some have more memory, some have more CPU, some have more disk space. Some will cost more, some will cost less. So you need to make your decision based on how much money do you want to spend, and of course, how much resources do you need to host your entire application. I will talk a little bit more about resource usage and resource limiting, but for now, I'm just going to leave the default. The node count will be the number of virtual machines that are going to be used to put your Azure Kubernetes cluster on top of. Why are there going to be more than one virtual machine? Because a Kubernetes cluster needs to be performant and it needs to be always available, which means that if one virtual machine crashes for some reason, you still have other virtual machines you can still use to keep your application running. So that's why, by default, you can have 3 virtual machines, but you can increase or decrease this number. I can go to 1, but of course, when something goes wrong with this virtual machine, your entire cluster becomes unavailable, which is not really the point of creating a cloud-native application. You really want to make sure that it scales and that it's performant and that it cannot fail. So I'm going to just leave it at 3. So this is the default size. If you have an Azure subscription yourself, you can also try to do this. Only keep in mind that virtual machines machines on Azure can be quite expensive depending on what kind of virtual machine you're using, and you will pay for every minute that you are using it. So if you just want to play with Azure Kubernetes, you can just create a cluster, play around for a couple of hours, and then destroy it again or remove it again, and then you will only pay for those couple of hours that you played with it. Of course, when you have an MSDN subscription, or when you use your first year on Azure as a new developer, you will get some credits from Microsoft that you can use to play around with, so that you don't have to pay for yourself, which is also perfectly usable for creating these Kubernetes clusters. So I'm not really going to spend a lot more time for the other options. Everything can remain like it is. So I'm just going to do review and create. That's it. And I'm going to click create. So now, of course, Azure needs to do a lot of work. Azure needs to create those virtual machines in the background, but it also needs to create a lot of networking capabilities. There needs to be an internal network that's shielded from the outside world. These virtual machines need to be able to talk to each other. Kubernetes itself needs to be installed on all of those virtual machines. So it will take some time. So I will leave this like it is. And I will come back to this later when hopefully it has finished. So let's go to Visual Studio Code and do something different. So yesterday we created a couple of very, very simple services, just because I want to tell a story and I don't want to dive too deep into C# specifically. So we created a web API, an HTTP web API, and we created a worker service. And that worker service will call the web API every few seconds so that we have communication between two services. Basically, it's a distributed application. There's two components that can communicate to each other. Today, I will add a third component to that, which is going to be a web application that can be used by a user. Nothing too fancy. I just need this kind of application because the web API and the worker service, they need to communicate to each other within my Kubernetes cluster. So they don't need access from the outside world. So it's just internal communication within my distributed application. But I also want to show you how to be able to contact your Kubernetes cluster from the outside world. So that's why I'm going to add a web application, and I'm going to allow users to access this web application from the outside internet. And that's the biggest reason why I'm going to create this. So now we're going to have 3 services, and all of these 3 services need to be installed inside of Kubernetes. I'm not going to do all of the code right now from scratch. I'm just going to show you something that I've prepared yesterday evening. This is also part of my GitHub repository. So if you want to learn, if you want to try it out yourself, just download my GitHub repository, look at that, try to deploy those applications inside of your own cluster to learn. It should be quite easy if you follow all of the steps. So this is step 19 of the process. So it's actually there's a couple of other steps first, but I already want to show you while we wait on Azure Kubernetes services to be deployed. So as I told you before, we already have the worker service, we already have the web API, but now we have an additional web application. I'm going to be completely honest with you. I am a backend .NET developer in my professional life. It has been a couple of years since I did front-end applications, so I really suck at JavaScript. So what I still do if I want to do demos is I create an ASP.NET MVC application. That's pretty old school. But for me, it's the easiest. And fastest way to create a web application. So here, I actually created an ASP.NET MVC web application, which has a startup class. And this can already show you that you can combine these different kinds of .NET applications. I told you yesterday that in .NET Core and .NET 5, basically every kind of application is a console application, or almost every kind of application is a console application. An ASP.NET application is a console application that runs its own web server to host your application. You can still host it inside of a bigger web server like AKS, but you also have the option to run it as a console application with its own integrated Kestrel web server. So this is, again, an MVC. It's an ASP.NET application. We still have the main method. We have the host builder, and it will use the startup class for configuration. But I also told you the worker service is also a console application that will host a worker. And this can be installed as a Windows service or as a Linux daemon, or you can just run it as a console application. Today, for this specific MVC application, I'm going to combine the worker service and the ASP.NET application into one. So this will be a web application, but it will also host a worker. So what is happening? Well, what I want to do is I want to create a user interface so that the user can see what the actual application is doing. And in the background, my MVC application will also call the web API. It will call the web API, and the web API will return the machine name from the machine that the web API is running to the MVC application. And I just want to show inside of the MVC application how many requests have been done and what machine name I got returned. So it's a very simple concept. But the cool thing in Kubernetes is that you can very easily create replicas of your services. So for example, my web API, if I know that many people and many services are going to use my web API, I can scale it out, which means I can have multiple instances or multiple replicas of that web API. And Kubernetes will automatically do load balancing between all of those instances. So if I know my web API is going to be very heavily used, I can create more replicas. More replicas means more requests that can come in at the same time, so more performance. Of course, you also need more resources to host all of these replicas. And this web API will actually show all of those machine names in some kind of a table. And inside of that table, you will be able to see which machine is accessed how many times. And that will basically show you that Kubernetes is load balancing. For this to work, I have created a request helper and a request worker. So if I look at the request helper, this is just a very stupid little class that keeps a dictionary of responses. And those responses will be the machine names. So you can see that it's a dictionary with a string as a key and an integer as its value. So the string will be the machine name and the integer will just be a counter. So we're just going to count, if I call the web API in Kubernetes, which machine name will I get as a result? And how many times will I get a certain machine name? So it's just going to be a table with a counter for each machine name. There's going to be some helper methods. Register will add a new machine name to the request dictionary, and get data will just return all of that data to the front end. So it's a very silly, stupid little class. It doesn't really do anything that is rocket science. The second class will be the worker itself. So this is a part of that worker service that are now integrated within my MVC application. So this will run continuously in the background. It uses dependency injection to also have access to that request helper. That's the class that I showed you just now. And when this loop is going continuously, every 100 milliseconds, which is a lot, I'm going to call my web API. And if the response from my web API is successful, I'm going to register that in my request helper, which means that if I leave this running for a couple of hours, I will have many requests, and those requests will be load balanced among all of my replicas for my web API. And that's it. The home controller is just a home page, and the home page will just be a blank HTML page that shows you one single table, and inside of that table, which is the index page for my homepage, it will just show you all of the data from my request helper. So nothing really fancy is going on here. There's just two request methods. The index action will load the complete MVC page, and the request data method is actually something that I'm using to refresh only the table. And so my page will use some JavaScript to refresh the table every 1 second so that I can see the numbers changing while I'm running my application. So that's it. That's the third part of my distributed application. I also included this project into my project TIE configuration. And so I now have a third web application, which, by the way, also uses my configuration concept, so that I automatically get the correct URL for my web API, so that my web project can call my web API with the correct endpoints. So let me just already show you what that looks like on my local system. So I'm just going to do TIE run to run these 3 applications at the same time. I will give it some time. That should be it. I will open the dashboard for Project TIE. And you can see that I now have my 3 applications running. The worker service is exactly the same thing as yesterday. It will return every 10 seconds the machine name from the web API. So this remains the same. And then my web project has a link to its homepage. So if I visit the homepage, you can see that it's now doing calls to my web API. And you can see the responses are going 28, 29, 30, 31. So it's continuously, so the worker service is continuously calling the web API. And of course, I'm running this locally on my own machine. There's only one instance of the web API, so it will always return the name of my laptop that I'm working on right now. The hit percentage is 100%. So 100% of the time, I will get to the same machine because, of course, I'm only running one instance. So that's it. Of course, in order to be able to deploy this into Kubernetes, I need to do the same thing as we did yesterday. I need to create a Docker image. And this is just the same as we saw yesterday. So I'm just going to very quickly do it as kind of a reminder to you. You can use extensions in Visual Studio Code. I can do Docker add Docker files to this workspace. Actually, again, this workspace contains my 3 applications. In order for this to work flawlessly, I'm actually going to close this Visual Studio, and I'm only going to open the web project. Otherwise, the Docker file will be created in the wrong location. This is something that I just know from experience. If you do this yourself, you will probably notice if you make the same mistake as I did the first time, and you need to try again. So this is how we learn stuff. So I open Visual Studio Code for only the web project. The Docker file is already here, but I'm just going to delete it for a second. So I'm using Docker add Docker file to workspace. Again, think about what kind of application platform are we using. We are using ASP.NET Core, so I can use that. We are going to build an image for a Linux environment because it's cheaper and it's performant and it's widely supported among multiple cloud environments. So Linux will be your most flexible option. Port 5000 is the port that is going to be used to access the web page. So that's the one that I want to expose. And I'm not going to use Docker Compose. I just want to create this one image. There we go. This will be created. This Docker file will be created for me. As I told you yesterday, you can just right-click, build the image. You can give it some time. It has been built. On the left-hand side in your Visual Studio Code, you can go to your local Docker. And then inside of your images list, you will now see the worker service, the web API from yesterday, but today also the web image. So now we have these 3 Docker images. If you want to run it, you can run it locally by calling run, but actually I want to push it to my Azure Container Registry, so ACR, because I need it to be there for my Azure Kubernetes cluster to be able to pull these images. So I do push, I choose my Azure subscription, I use my registry. I said I use my registry. Okay. Be very patient. I'm not a patient person, so I always get like, all right, I will come back to this later. Oh no, there it is. So yeah, this is my registry. I use it, I pick a name. for my container, I press enter and I can push it to my Azure subscription. So I actually already did this yesterday evening. So I can go back to Azure. As you can see, our Kubernetes cluster is finished. It is completed, the deployment. We can go to that resource. And we can actually start using it. The Azure portal itself doesn't really give you a lot of options to work with this Kubernetes cluster. A lot of the things that we are going to do today will be command line based. So don't worry, I have all of the steps documented in my GitHub repository. But yeah, there will be a lot of command line today. Let me also already show you that the containers are, or at least the Docker images are on my registry on Azure. So let me remember our resource group. Inside of my resource group is my container registry. And inside of this container registry, I have my repositories, which is my worker service, web API, and web application. So that's perfect. Okay, so let's go to Visual Studio Code. In Visual Studio Code, you can also install an extension that allows you to interact with a Kubernetes cluster. On the left-hand side, yesterday we used the Docker extension. Today we will use the Kubernetes extension. By default, it sees that I have a local Kubernetes cluster running on my laptop. That's because I installed Docker for Windows, and Docker for Windows allows you to enable a local Kubernetes cluster on your local machine, which is fine. But now I have created a Kubernetes cluster in Azure, so I like to connect my Visual Studio Code to that cluster in Azure. So if you look at the bottom, you can see that there's an option called Clouds. So you can connect to your Azure cloud. I can't show you today because I actually can't figure out how to disconnect from this Azure connection. But if you just double-click connect to the cloud, it will ask you to download a specific extension for Azure. So you can install that extension. Then you can connect to Azure. It will open the browser for you. You need to log into your browser, and then it will redirect to Visual Studio Code, and you will then have access to all of your subscriptions. So this is my subscription that I'm using for this workshop. And if I refresh, okay, this is weird. Let me disconnect. It should actually show me a different cluster. That's a shame. Okay, let's see. Let's take a look in Azure itself. Well, basically, I prepared this yesterday evening, so there's already a cluster running in my resource group. So I have my Azure Kubernetes Service Cloud Native.next. That was the one from yesterday. And I have my AKS.next workshop. That's the one from today. So it exists in Azure. So I also need to be able to connect to it right here. Okay, so for now, I'm just going to connect to the one from yesterday. If you want to connect to this cluster, you need to right-click and tell it to merge into kubeconfig. So kubeconfig is your local Kubernetes configuration. And if you want to access a cluster in a cloud environment, you need to merge that into your local configuration. So I'm going to do that. And then it will appear in the top with your local clusters. So now I have access to my Cloud Native.next cluster right here. You can open it. Let's see. Okay, maybe this is what's going wrong. Nope. Okay, so I'm going to do that one more time. I merge into my local kube config. Here, the local cluster is the cluster that is actually being used right now inside of this UI. So the next step you need to do is to right-click your cluster in Azure and say set as current cluster. So this is the cluster you want to work with right now. So set as current cluster. It will switch from the local one to the one that you have on Azure. And now things become interesting. So inside of your Kubernetes cluster, there's a couple of concepts that you need to know about. First, there's going to be namespaces. And it's really a shame that for some reason this thing will not refresh, because I really want to show you a clean cluster and not the one that I've prepared yesterday. But I have no idea why. So let's forget about it. And it has the cluster has multiple namespaces, and a namespace you can compare a little bit with namespaces in C#. You can use that to group all of your services together if they have some kind of need to be logically together. It's not something physical, it's just something logically that we can use for our own benefit. So for example, I have created a new namespace called .next. So I'm just going to use this namespace as the current default namespace. So you just right-click on a namespace and you select use namespace, and then this will be your default namespace. So when I do anything within my cluster right now, it will always default to this namespace. If I create services, it will be created inside of this namespace. If you click something like this, if you double-click something like this, which is a resource inside of my cluster, it will always open a YAML file. And this is how Kubernetes works. Kubernetes works based on YAML files. And the YAML file actually describes what is there. It does not describe what needs to happen. It describes what is already there, or what needs to be there. So it's kind of a situation that you describe, and you apply that situation to your cluster, and your cluster will always try to get everything ready as you describe it to be. And so it's not like when we write C# code, for example, you actually write what your computer needs to do. In a Kubernetes cluster, you just tell the cluster, this is how you should be. And then the cluster will try to work towards that. And so, for example, if I want to create a new namespace, I can actually clean this up a little bit. So I want to create a new namespace. This is all I need. Then I'm just going to say, okay, I'm using API version 1. I want to, this thing is a namespace. It has metadata, and the metadata for the name is, for example, example. I have no idea what this is. And then the current phase of this namespace should be active. So it's going to be an active namespace with the name example. If I want to apply this to my cluster, I can use an extension with my command palette and if you search for Kubernetes, you will find Kubernetes apply. So you just apply this YAML file to your cluster, and your cluster will immediately react by trying to work towards what you are asking it to do. And so apply. It will also say to you, okay, the namespace example does not exist. This will create a new resource, because now Kubernetes will see, okay, you want a namespace example. That does not yet exist. I will create it for you. So if you do that, it's going to be created. But it also works differently. If I have a namespace example and I add some other metadata to this, I have no idea what other metadata is from the top of my head. But if I do something like this and I apply, then it will say you have unsafe changes, and then it will just do the delta between this. Again, you are not sending commands to Kubernetes, you're just sending a situation, and Kubernetes will automatically change towards that situation. So in this case, it's going to be an edit. In the previous case, it was a create. If we refresh our namespace list, you will now see that there's also an example namespace. So this is how you create resources in Kubernetes. So just one time, I'm going to try again to refresh this. Doesn't work. Okay, it doesn't matter. So now that we have selected our .next namespace, I can talk to you about nodes. Remember that while creating the cluster, I just left the default values. I created 3 nodes with a specific size. And here you can see those nodes. So these are actually virtual machines that can run different parts of your application. And what actually happens is that Kubernetes will automatically assign one of your services to one of the pools, or it's not the pools. One of the pool contains all of your virtual machines. This is one virtual machine. So Kubernetes will assign your service to one of these virtual machines. And if I open these virtual machines, you will see that on each of these virtual machines, there are some services running. And in Kubernetes, these services are called pods. It's a difficult word to pronounce in different languages. So pods, P-O-D-S, multiple pods. So the singular form is pod. And these pods, they will contain your services. So it's basically a wrapper around a container, or a wrapper around multiple containers if you want. So you can even have multiple Docker containers inside of a single pod. By default, you actually want only one container for one pod, because that will give you the most flexibility. If you put multiple containers inside of one pod, that pod will run on one virtual machine or one virtual machine inside of the pool, and it's less flexible. You cannot move these things around, and you cannot split one container to one virtual machine, another container to another virtual machine. You can only do that if you put them in different pods. So you can see that there's lots of stuff already running inside of these virtual machines. So there's web API. You should recognize these. These are the things that we created yesterday. This is my website. This is my web API. You can see that there's on the second virtual machine, there's the worker service. And there's also a web API. And then on the third agent pool virtual machine, there's lots of other stuff. So actually, Kubernetes also needs to manage lots of things by itself. It needs to manage your pods automatically. It needs to manage your network, your communication. If you apply new YAML files, it needs to automatically deploy them inside of its own cluster. So it also uses the concept of pods to make all of this work. So a lot of this stuff that is running on your virtual machines is also part of Kubernetes itself. So now you can see that my services are already a little bit scaled, because some of them are on the first virtual machine, some of them are on the second virtual machine, and actually the web API is on both the first and the second virtual machine. So if the first one goes down, I don't have my website, but I still have my web API and my worker service running. There's different views in this cluster, right? You can also look at workloads. And in workloads, you have the concept of deployments. So if you want to put your container inside of your cluster, you are going to create a deployment. And a deployment is a description of what your pod should look like, how many replicas you want, what container it needs to pull from a container registry, and what your configuration should look like. So if I open deployment, you can see that I have three deployments. I have a deployment for my web, deployment for my web API, and a deployment for my web worker service. And if I open worker service, for example, I can see that there's one deployment. And this one deployment has one pod, which is my worker service. If I double click this one, then you can see the YAML file for this deployment. It actually contains lots of information, but when we apply new ones ourselves, it's going to be a lot easier. Now, if I look at Web API, for example, you can see that it has two pods inside of the deployment. Actually, I was lying to you. By accident, I double-clicked on the pod itself. This is the description YAML file for the pod. If you want to see the deployment, you need to double-click one level up. This worker service is the deployment. So this is the deployment. So for my web API, this is the deployment. And inside of my deployment, I have two pods running, because I specifically asked Kubernetes to have two replicas. So if one goes down, the other one is still active. And this will also be very fun for my web application, because my web application, which is here, which also has only one replica, will call my web API and it will be automatically load balanced. So my table will now have two different machine names, and it should be 50-50. It should be 50-50, whatever is going to be reached. Now, just to recap, I have my namespaces, which is kind of a resource in Kubernetes. I have my deployments. For my deployments, I'm using replicas if I want to have multiple replicas. I'm using Docker containers to pull from a Docker registry or a container registry. And I'm using the concept of multiple pods that can run. The cool thing about Kubernetes is that these pods will always be kept alive, and if something goes wrong, a new pod will be started automatically. And this is because it works based on these YAML files. Again, as I told you before, you do not describe what needs to happen, you just describe the actual situation. And the actual situation for the web API describes that there needs to be two replicas at all time. So if I right-click the first replica, please remember the machine name. Please remember JMZZ2. JMZZ2. I'm going to right-click and I'm going to do delete now. I'm deleting this pod. JMZZ2. It is taking some time. Now you can see it's gone, and immediately another pod 4ZZ4Q has appeared. It is red because it was still starting, but if I now refresh, you can see that it turned green. So Kubernetes immediately starts a new pod with, it pulls a new image down, it configures this, and it starts it in a matter of seconds. It only takes 1 second, 2 seconds maybe, and it's ready to run. But it now has a new machine name. So it just changed immediately. And this is what I find very, very cool about Kubernetes. It will always try to keep your configured situation correct. Now, one last time, I'm very sorry, I'm going to try to refresh this, and my second cluster does not appear, and I really, really have no idea why. Let's see. Is there something that I can do about that? Yeah, you know what I'm going to do is I'm just going to destroy everything, or maybe not. Let me just show you how to create these deployments. So let's start with the worker service. So the worker service is a deployment. If I delete the deployment, the pods will automatically be deleted with that. Because I'm deleting the YAML file, Kubernetes does not need that worker service right now, so it will remove all of the running pods. So you can always verify in your nodes that now there shouldn't be a worker service anywhere. So there's no worker service because the deployment has been deleted. So what does it look like if you want to create a new deployment? So let's go to part 3, step, I think step 18, maybe 17, no, it's going to be 18. So you just create a YAML file, and how you need to write these YAML files, you can just find it online. And if you already created your own deployments in Kubernetes, you can just copy paste from your own experience and change the values basically. So here I'm describing the kind of resource in Kubernetes is going to be a deployment. I'm going to give it a name, worker service. And this is the specification for this deployment. Within that specification, I'm going to ask for one replica. One replica means I only need one instance. Then there's a match label, which says, okay, this is going to be an application called worker service. Don't need that right now. And then there's going to be a specification for the template. So I'm going to use a template to create this service within my deployment, which has one replica. And that is going to be based on a container. So I'm going to use a Docker container as the template for this deployment. The name for this container will be worker service. The image for this container will actually be my Azure Container Registry. So my Azure Container Registry, which I already have on Azure, has my Docker images uploaded or pushed to them, so they are available right there. So I just need the full name of the image that I want to use to push as part of this deployment. And these are the environment variables that I can set. I will talk about this a little bit later. And then I can put some resource limits. I can, for example, say that the memory usage for this specific container cannot be more than 128 megabytes, and the CPU usage can never be more than 25% of a CPU. So it's actually 250 milli CPUs, which is 1/4 of a CPU. And then it needs to open port 80. That's it. It's the same thing as before. If I want to deploy this to Kubernetes, I need to apply it to my deployment workload. So you can see there is no worker service available right now. So I just do command palette, Kubernetes apply. Kubernetes will tell me the resource worker service does not exist. Do you want me to create it? Yes. And it should now appear on the left-hand side. There we go. Here's my worker service, and it's already running. So it's practically immediately that it's available. If I right-click my worker service, just like when you run Docker containers locally, you can use this plugin to follow the logs. So you right-click your pod, you do follow logs, and you are now inside of this container, and you can see the console output. You can see that it is actually calling my web API. And you can also see that sometimes it returns NTVDG, and sometimes it returns 4ZZ4Q. And these are basically my two web API replicas that are here. So sometimes it will automatically call one of them, and the other times it will call the other one. So again, this is being load balanced by Kubernetes automatically. So I didn't have to do anything for that to work. You can, of course, you can customize the whole process if you want to. There's lots of tools, lots of extensions for Kubernetes to do whatever you want with this load balancing stuff. But by default, it will just do, I think, some kind of round robin, or maybe not, because it's calling the same one after the other. But yeah, I also have my web pod is also calling this web API, so maybe it is round robin. I just don't know. But by default, it already works with some basic load balancing. Of course, there is going to be an additional step in order to do that, because right now, and that's the problem with why I really wanted to do this from scratch. Oh, it seems like it lost the connection. Yeah, now it's here. I'm very sorry. Yeah, we don't really have a lot of time left, so I'm just going to keep doing what I'm doing right now. But I guess I needed to be more patient, or I needed to create the cluster beforehand, whatever. By default, when you create a deployment, and inside of that deployment is a service that needs access from the from outside of that container, not from the outside world, but within your Kubernetes cluster, but from another container, that will not be possible. A pod like this web API, it's completely sealed. There's no communication possible from outside by default. I'm telling inside of the deployment. I'm not telling anything about access from outside. So what I actually need is another kind of resource to be able to access one of your pods. And this resource, you can find it within network, and it's called a service. So a service is an additional resource in Kubernetes that you need to put on top of your pod to have access to that pod. It's a very lightweight thing, and you can see that I have for my 3 deployments, web API, and worker service. There's only 2 services. There's web and web API, because the worker service does not need access, doesn't need HTTP or TCP access. But my web and my web API, they need access. So if I look at my step 17, this one contains the deployment for my web API, and it contains the service. So what is the service? The service is very, very easy. The service is a resource, so it's a resource of kind service. It has a name, and our name is web API, and then it has a specification. Again, it looks very similar to a deployment. This specification has a selector, and a selector means if something hits this service, if this service gets a request, what needs to happen? Okay, I need to select an application, and that application is going to be web API. So I'm sorry, my naming conventions are not perfect. This should maybe be like web API service, and this should be like web API app or something, because the names of these things are important. This is the name of the service. This is the name of the app. If you look at your deployment, web API is the name of the deployment, and inside of that specification is my selector, which says that the app inside of this deployment is called web API. So this web API label is actually this selector app, which means that if, again, a request enters this service will know that it needs to select an app with the name web API, which is this app inside of this deployment, which has two replicas. So now Kubernetes knows, or at least the service knows, okay, I need to forward this request to that pod, to that container. And then finally, you need to specify port forwarding, which means that the service will listen to port 80. And so the service itself will listen to port 80, which is the default HTTP port, but the target port on my app will be 5000. Because my Docker container does not expose port 80, it exposes port 5000. So this is like your port forwarding on a Docker container. So again, just to repeat, this service selects an app, which is a web API app or pod, and it will redirect all requests from port 80 to port 5000 on that container, on that pod. And it's the same thing. You just do Kubernetes apply. In my case, it's already there, so I'm not going to do anything. And it will be part of your Kubernetes cluster. Again, I'm going to show you network services. If I open this web API service, I will see that there's two pods running beneath this service, because Kubernetes automatically knows this service selects the web API app, and the web API app, which I can find under deployments, web API, has these two pods. So you can see that they are the same thing. These pods are the same thing as these pods, because it's just like a shortcut to this one. But also when we deploy the worker service, so if I double click the worker service YAML file, and I scroll down, here, you could see that we were using environment variables because I need to communicate with another container inside of my Kubernetes cluster. And the way you communicate using HTTP is very easy. Your DNS is basically the name of your service. So I have created a service with the name Web API. So my DNS, the domain name that I need to use to access this container is just the name of the service. So the Web API service URI that I'm using from my worker service is just HTTP Web API. That's it. Web API is just the name of my service. All of these requests will enter my service. My service will redirect to the correct pod. Actually, it will first redirect to a load balancer, and then the load balancer will redirect to the pod, and the pod will redirect to the container. And now my request is inside of my container, and I can do a response. So it sounds very complicated, but it's very easy to use. The only thing you need to do is install a cluster, Kubernetes cluster, and then start creating YAML files to do your deployment, and everything should work. Let's see, how much time do I have left? 16 minutes. Yeah. Now things become very complicated, and for this I'm going to go to my GitHub GitHub repository. So let me just, because I wasn't able to do it on a new cluster, I needed to show you on an existing cluster. I'm very sorry for that. I'm just going to go through all of these steps if you want to try it yourself. So the first step was to create the Kubernetes service in Azure. We did that together. The second step I skipped because it wasn't really necessary. But if you are creating your own cluster, it is necessary. Basically, if you create an Azure Container Registry that contains your Docker images, your Azure Kubernetes cluster does not have access to it. By default, it's private. So from the outside world, you cannot access your cluster. So in Azure, there's a very easy way to contain a trust relationship between your Azure Container Registry and your Azure Kubernetes cluster. And you just need to run this command right here from your terminal. So Azure AKS update, so you're updating your Azure Kubernetes services. You need to provide your resource group name, you need to provide your Azure Kubernetes cluster name, and then you need to attach an Azure Container Registry with this name to that. And then Azure will contain a trust relationship between those two. And this is very important, of course, because when we apply a deployment like this, it's going to be Kubernetes itself that will pull the Docker image from our container registry. If you are using external container registries like the one from Docker Hub, for example, it's going to be different. You can just use the URL to your Docker Hub container right here, and then you don't need that trust relationship because Docker Hub is public by default. So if you put something on Docker Hub, it's publicly, everyone can pull that image, so your cluster can also pull that image. But we are using Azure Container Registry, so we need to have that trust relationship. The next step was to deploy the web API to our Azure Kubernetes cluster. That's what I did. You need to create a namespace first. I showed you. Then you need to create a deployment for your web API. I showed you. And then finally, you need to create a service to be able to access these pods, which is something that I showed you. The next step was to deploy the worker service. We need to have a deployment that contains environment variables with that web API service URI property, which has the web API service domain name for you to use. So that's an internal thing. So this HTTP is only accessible inside of your Kubernetes cluster, inside of that private network, inside of that cluster. And that's it. And now things become quite complicated. If you do this yourself, you're probably going to need to retry a couple of times if you make some mistakes, but it needs a lot of manual steps. And it's basically, we have deployed a web application to our cluster, and that web application is not accessible from the outside world. It's if we create a service for that, which is what we do here, we create a deployment and we create the service for our web application. It is only accessible from inside of our Kubernetes cluster. So it's basically useless. I cannot use this website because I cannot access it. So what do we need to do? Well, on Azure, we need to create a public IP address and DNS entry. So in Azure, these are the commands that you can use to actually figure out how your cluster is built. So I'm just going to show you, instead of using these commands, I'm just going to show you in Azure itself. If I look at my resource groups, remember that I had the cloud-native.next resource group. And inside of this resource group, there's two Kubernetes clusters. There's the one that I prepared yesterday, the cloud-native.next, and there's the new one that I created together with you today, .next workshop. So I have two clusters. But if I go back to my resource groups, I can see that there's these resource groups that I have not created myself. They have a very weird name. It has like MC_RG cloud-native.next AKS cloud-native.next West Europe. And then there's the other one. Because I have two Kubernetes clusters, I have two of these resource groups. And if I open the one that I created today, so AKS .next workshop, you can see that it has 8 resources. It has a network security group, it has a routing table, it has a virtual machine set, managed identities, virtual network, public IP addresses, load balancers, and so on. So this is a resource group that's been created by Azure itself to manage all of the networking from your cluster. So if we want to have a custom IP address that is accessible from the outside world, we need to add it to this resource group because it makes sense. This is where all of the networking from my Kubernetes cluster is managed. So if I want to add something to that, I'm also going to add it to this resource group. So this is a command line version of how you can create your own public IP address in Azure. And so I create Azure Network Public IP Create. Inside of this resource group, you can just copy paste that name from your Azure portal or use the commands in the top. You give it a name. So my name is ip-cloud-native.next web. It's going to be a standard one, blah, blah, and that's it. If you run this, a new IP address will be assigned. So I can show you the thing that I prepared yesterday. This one has 9. And I created this IP. So ip-cloud-native.next web, which is this IP address. So now I have a public IP address available, but you are not ready yet, because the only thing you now have is a public IP address assigned to you, but it doesn't lead you anywhere. If you would browse this IP address, it will just time out because there's nothing behind it. The second step that we need to take, just to make our lives easier, is assign a DNS name to that. We don't want to use IP addresses, we want to have a friendly DNS name. So you can actually find the full resource identifier for your IP address, which is a very long one. It's this one. You can find it using these commands. And then you can update your public IP and give it a DNS name. And so Azure Network Public IP Update, you give your full resource ID for your public IP, and then you give it a DNS name, and I've chosen to use cloud-native-.next-web. So if I execute that command, you can see that now I have this DNS name. We are still not yet finished. Now we have an IP and we have a DNS. If I visit this URL, it will still time out because there's nothing behind it. So in the next step, I'm going to do the most complicated part of Azure Kubernetes. I basically need a reverse proxy. A reverse proxy means that if something on my IP address, if a request comes to my IP address, I need a reverse proxy. I need to redirect that request to the correct Kubernetes cluster, and inside of my cluster, I need to redirect it to the correct service. And for this, Kubernetes has the concept of Ingress controllers or reverse proxy controllers. There is many tools outside. There's many tools in the world that you can use to do this. I've chosen Nginx. Nginx is a software that you can use for reverse proxies. So you need to install that one inside of your Kubernetes cluster. As I told you before, Kubernetes is very extensible. If you want to do custom stuff, you can install all kinds of these softwares inside of your cluster, and then you can use them. So the first thing that I did was to create a new namespace. So everything that is specifically to reverse proxy and Nginx Ingress, I'm going to put in a separate namespace. It's not going to be part of my distributed application. It's part of my Kubernetes cluster. So I want to make like a division. I have my application and I have my Nginx Ingress application. In Kubernetes, you can use Helm, which is a utility to install stuff inside of your cluster. Again, it's a little bit like NuGet packages. Helm is like your NuGet package manager. It has repositories where it can find packages, and we are adding the repository that contains the Nginx Ingress controller. We are updating our repository, and then we can install using this command line. So we are installing Nginx Ingress in the namespace Ingress that we just created, and we are setting it to have a replica count of 2, which means that the Ingress itself, the reverse proxy, will also be load balanced in 2 replicas. it will also run inside of pods. So everything in Kubernetes works the same way. If you install external software, it will also run in deployments and pods and can have replicas, stuff like that. It has a number of parameters, but all the way in the end, this one is very important. Your load balancer IP for your reverse proxy will be the IP address that we just created 5 minutes ago. And now we have created a link between our public IP address in Azure and this reverse proxy load balancer. So this Ingress reverse proxy Nginx thing is now connected to my IP address. And if you visit your IP address or the DNS name that we created, you will not get a timeout. You will get a 404 not found from Nginx, which is a good sign, because now you know that you are hitting your cluster, your Kubernetes cluster, and you are now inside of your Ingress controller. But you did not yet define which request needs to be sent to which pod. And that's the final step. So in the final step, there's yet another kind of resource inside of your Kubernetes cluster. We had namespaces, we had deployments, we had services, and now we have Ingress. So Ingress is actually a rule that you specify. Okay, I have my Ingress that uses this host name. So I'm not going to use the IP address, I'm going to use the host name. So if something, a request comes into this host name, I'm going to look at all the HTTP traffic, and I'm going to make rules for paths. And paths, it will say, okay, if something comes in on this API, I'm going to redirect it to the backend service with the name web. And that service will listen to port 80, and this will be my path selector. So basically, if whatever I type / whatever behind this host name will be redirected to this service with this name. So I can show you in Visual Studio Code. In Visual Studio Code, I have created the Ingress, which is my web Ingress right here. It's the one that I showed you just now. And it redirects to a service with the name web, which has its own load balancer, which will eventually reach your container. So without further ado, let's keep our fingers crossed. I prepared this yesterday, so if I visit this URL, it will show me my web application. And because I prepared this yesterday, you can see that there's already a lot of data. Yesterday, I deployed 2 replicas. And you can now see that all of the requests from my MVC application will be 50-50 on these 2 replicas. This is the one, and this is the other. Remember JMZZ2? I told you about this a little earlier today. JMZZ2, you needed to remember because I deleted it. And that's why you can see that 17,900 requests since yesterday evening have been to this specific pod, and 17,128 have been to this JMZZ2 pod. So it's about 50-50. But of course, about 30 minutes ago, I deleted the JMZZ2, and Kubernetes automatically created a new one with 4ZZ4Q. So since that I deleted this one, 669 requests have hit this new one, which is about 2%. So basically, the bottom 2 combined will be 50%, and the top one is 50%. And this is a basic example of what you can do with Kubernetes. Of course, you really shouldn't do all of this by hand. Of course, you need to use continuous integration, continuous deployment principles. You can see that we have the YAML files. You have external tools that can help you to manage your Kubernetes cluster. So if you want to deploy new services, you need to use automatic pipelines that apply these YAML files to your cluster so that you don't have to do it manually. But of course, for this workshop, I just want to show you how everything works. So I showed you manually by creating the YAML files, applying them to your cluster. Your cluster will automatically adapt to these YAML files, and it will run your applications. I'm just going to, we have 2 minutes left, so I'm just going to show you what can happen if you make changes. If I go to my workloads, my deployments, my web API, I double click this deployment, which has 2 replicas. Let's do something crazy and make it 5 replicas. Let's do Kubernetes apply and see that Kubernetes automatically sees that I've made a change. 2 becomes 5. I apply. And I wait. I can refresh this page. I'm not sure if it's going to work, but now there should be new machine names appearing because there should be new replicas for my web API. It's not really happening. So let's see. Maybe I don't have enough resources or the wrong namespace. Nope. Okay. This didn't go as planned. Okay, let's try again. Let's try again one more time. It should work. Probably I'm making a stupid mistake, but we'll see. Yeah, it didn't. Still 2. So let's see. Oh, the wrong one. Apply. Configured. Yeah, the reason probably is because I already have lots of pods running on my nodes. So if I look at my nodes, there's already lots of stuff running. If you basically assign your resource limitations, you say I have 25% of a CPU needed for 1 pod, and my virtual machine that is running my pods only has 1 physical or 1 virtual CPU available. Yeah, when you can reach a certain limit. So at a certain point in time, you will not have the opportunity to add more pods to your system. You need to have more nodes. So you could see that right now I had 3 nodes in the Azure portal. Inside of your cluster, you can basically drag it to have more nodes, 4 nodes, 5 nodes, 20 nodes, whatever. So the reason that it's not working right now is probably because there's no more resources on my virtual machines to assign extra pods. So you need to know about that. So I'm sorry for that. But we are out of time. So with this, I hope it was very informative for you. I hope you will play around with this, and I thank you for being here, and enjoy the rest of your conference.
Thank you, Johnny. If you want to ask some questions, you could continue in discussion zone. Thank you, Johnny. Thank you, Anna. Bye-bye.
Bye, guys.
Bye-bye. See you in the discussion zone.